Hi, this is just a brief review of how to simplify rational expressions. There were 3 steps that we talked about as we simplified rational expressions. One was first make sure it's written as a fraction, and in our first problem here it already is. The second step is to factor, so we're going to do that next. So if you're going to factor this problem, I'll make sure my pen works. So if I'm going to factor this problem, the first thing I notice in my numerator is that I could take out a GCF. Always look for a greatest common factor first, especially if you're getting stuck on a problem. So I noticed that in this first problem, both of the terms have an x, so this would become an x minus 2 for my numerator, but that's being factored. And in the denominator, notice I look for a GCF first. I don't see a GCF, but then I do notice that I can have an x minus 2 times an x plus 2 because that multiplies to a negative 4 but adds to 0. So it was already written as a fraction. I now factored it, and the last thing it says is to cancel like terms. So it has to be like factors again, so the same exact quantities cancel out. And so my final answer for this first example is just x, and then the only thing that's left in the denominator is x plus 2. The other thing that we talked about in this chapter, this section, was talking about the domain. And again, the domain for a function is all the x values. And it's what we called all the possible x values. And the reason we say possible is because in this problem, there are some x values that are not possible. We can square every number that we can think of. We can multiply every real number by 2. But a problem comes in. So there's a problem that we have is you can't divide by 0. And so what we said is if you're trying to figure out your domain, every number will work into this expression. You could substitute every x value in except, so the domain is possible x values, so all real numbers work, real numbers except the ones that make you divide by 0. And so when you look at that, you look at the factored form, you say, wait, if I plug in a 2 here, 2 minus 2 is 0. 0 times this would be 0, so I'd be dividing by 0. So every number work, all real numbers work, except if x equaled 2, and except if x equaled negative 2. So we could write our domain like this, but typically the way that we've been seeing it is rather than writing all that out, people just say, well, everything works except, and so they say x can't be 2 and x can't be negative 2 because that would make us divide by 0, and that's a bad thing. So we're going to do another example. Our next example is a little bit larger, but the first step again is write as a fraction. So when we look at this, we recognize that there's a negative 1, and we just went over our exponent rules in the previous video. And so when we see an exponent to the negative 1, what that tells us is that that whole entire quantity, 6x squared minus 5x plus 1, can be written in the denominator. So now we have it written as a fraction. Now, the second step is factoring. Now, when we're going to factor, it is always recommended that you put your exponents in order. So in the top, I would actually put my negative 2x cubed first because that's a larger exponent, my negative x5 second, and my positive 3x last. The bottom is already written in standard form with the highest exponent first, so I'm just going to rewrite it. And now I'm going to start my factoring step. So I notice in the numerator, the first type of factor, again, that I can take out would be a GCF. And I notice there's a GCF of ax. And now I'm left with negative 2x squared minus 5x plus 3. And I'm just going to write the bottom here because there's no GCF. Okay, then the next thing that we should notice is that we have 2 quadratics, one on the top, one on the bottom, and we can use our AC method. So I'm going to factor first this first expression on the top. So AC is negative 6, and it has to add to a negative 5. And again, I really suggest that you write out all your factors. So 1 and 6, 2 and 3. But if it's negative, that means one of them has to be negative. So it either could be negative 1 and 6, negative 2 and 3, or it could be positive 1 and negative 6, positive 2 and negative 3. And I noticed that this is the only combination that would add to a negative 5 and still multiply to a negative 6. So if I'm factoring this numerator, I first start off with thinking, well, it could be x plus 1 times x minus 6. But I realize that that doesn't give me back my negative 2. And what we realize next is you have to use the bottoms-up method. Again, you could do guess and check, and many of you are really good at that, but I'm going to just go through the bottoms-up. Bottoms-up would be take that coefficient, that negative 2, and divide both of those terms by negative 2. And then simplify your fraction. Well, this fraction doesn't simplify, so that would be negative 2x plus 1. And this one does simplify to an x plus 3. And as I look at this, I should notice that it does distribute back to my original expression. So my numerator now is x times negative 2x plus 1 times x plus 3. So that was me factoring the numerator using the bottoms-up method. Next, I'm going to factor the denominator using the AC method again. So AC for my bottom is 6 for my denominator. B this time is actually a positive 5. And again, I'm going to write out my factors, 1 and 6, 2 and 3. Or I could have a negative 1 and a negative 6, and a negative 2 and a negative 3. But I notice this is the only one that gets me to a negative 5. So I actually have to use this one. Wrote it wrong, negative 5. So I would have x minus 2, x minus 3. But that doesn't distribute back to this, so I have to remember in bottoms up, you have to use that 6, divide both by 6, simplify my fraction, so that would be a 1/3, and x I would have a minus 1/2, and then I would have bottoms up 3x minus 1 and 2x minus 1. So my denominator is 3x minus 1 and 2x minus 1. So it said factor. I did factor and it said cancel like terms, and I noticed there are no like terms, but I do notice that these two are very similar. I noticed that they are actually exact opposites, and that should be a hint to you. When I see problems that are exact opposites, so like a negative 2x plus 1, and I see the 2x minus 1, they're exact opposites. Again, exact opposites, negative, positive, positive, negative. I could factor out a GCF of a negative 1. If I do that, I get 2x minus 1, and what happens is my numerator becomes, again, there's an x times a negative 1 times the 2x now minus 1 times x plus 3 all over 3x minus 1 times 2x minus 1. Now I see terms that cancel, and I would write my final answer as negative x, because you multiply those two together, x plus 3 over 3x minus 1. And again, you could keep it in parentheses if you want. So when you factor or when you simplify rational expressions, you write as a fraction, you factor, and sometimes that means factoring has to happen multiple times. For example, we took a GCF, then we had a quadratic, so we factored our quadratic. After we had our quadratic, we realized we could take another GCF. So this factoring step could take multiple times, and then finally you cancel your like terms.